Okay, so here are a few examples from what we did in class in case you were absent or you're going back to do some stuff and you're confused. So what we're looking for is counterexamples, something that makes this not true. Okay, so for 4a, you have a couple of them that are easy to do. One is if you let n equal 0, the opposite of 0 is still 0. So negative n would be 0, which is not negative. Another one is this, if you let the number be negative, so let's say we're going to let n be -3, which is a real number, because real number is any number we've used. The opposite of -3, which is what we're looking for here, is +3. That is not negative. 4b, this one's a little trickier because kind of like once it's been put in your brain that it's vertical angles that we're looking for here. Again, we have two congruent angles, and the question is, are they vertical? You have to kind of distort your picture. So here's the example I used similar to this in class, or that hopefully someone came up with. So here's A, B, C, and this is D, B, E. Okay, so D, B, E. So if these are like, 30 degrees, they're both congruent. Sorry, they're both congruent, but they're not vertical angles. Vertical angles would have to be something like this, okay, which they're not. Okay. Next example to take a look at we talked about is making a conjecture from some kind of given information. So for 32, we're supposed to do the product of 2 and any number plus 1 and see what we get. So I'm just going to do this. Number plus 1, answer. So if we do 3, so 2 times 3 is 6, 6 plus 1 is 7. 2 times 3 is, or I'll do 5 then. 2 times 5 is 10, 10 plus 1 is 11. Same thing over here. Number plus 1, answer. I'll do an even. This time I did two odds. Let's do an even. 4 and 6. 2 times 4 is 8. 8 plus 1 is 9. 2 times 6 is 12. 12 plus 1 is 13. So our conjecture here would be that it's odd in the end. Result is always odd. And again, you can prove this. You can actually do some fancy algebra and show that works. 34. 34. We've got two numbers A and B. When we multiply them together, we always get 1. The question is, what's the relationship have to be? Well, the first thing to think of is, what are some numbers that multiply together to give you 1? And probably the easiest one to think of is 1/2 and 2. They have a product of 1. Maybe 1/3 and 3 then would jump out of your mind next. 1/3 and 3 have a product of 1. Then you start to get fancy. You might say, oh, wait a second, 2/3 and 3/2 also equal 1 because the 3's and the 2's cancel. And 5/7 and 7/5 equal 1 because again, those cancel. 3 over 1, 2 over 1 also cancel. So these are all a bunch of numbers that have a product of 1. What's the relationship between 1/2 and 2, 1/3 and 3, 2/3, 3/2, 5/7, 7/5? A and B must be reciprocals. Okay, so that's the relationship. Okay, and the last one to take a look at is just some statistical stuff that we did in class. So we've got here, okay, students playing hockey over the age of 7. So we've got the year 2000, 2002, 2004, 2006. And we had 1.9 million in 2000, so I'll do 1.9 to 2.1, 2.2, I should have spaced that a little bit, I'm running out of space, 2.3, 2.4, 2.5, 2.6. Okay, this is definitely not a very good statistical. I have it for my little break there telling me that I'm breaking it too. So we now can look at our little graph. So in 2000 we had 1.9 people. 2002 we had 2.1. 2004 we had 2.4. And then 2006 we had 2.6. Okay. Now you don't have to connect the dots, but if you decided to for some reason, the question is what's happening? Okay. Well, my conjecture is the numbers are increasing. Number of participants over 7 playing hockey is increasing. What's my support? Okay, the graph is rising every 2 years. I can physically see it rising. Okay, and that is section, that's in problems section 2.1.